right, today we're going to be talking about mole conversions. Mole conversions is what we introduced yesterday, but it's also going to be one of two big math parts of this test. Mole conversions, again, they allow us to convert different pieces of information about a substance that we might collect in a lab and convert it into something else that is also going to be useful. One of the key aspects of this unit is Avogadro's number, 6.02 times 10 to the 23rd. This is a number that you do not need to memorize, obviously, because this is open notes, but it's a number that we will use somewhat extensively in here, in this unit. If you turn to the back of your pink sheet, you will notice this little diagram. This is what we will refer to as the mole map. This is something, obviously, you're going to get to use on the test. And it's just a visual reminder as we go through these conversions of how do we convert between atoms and molecules and moles and grams. And as you can see, what the mole allows us to do, allows us to convert to a whole bunch of different things. So the mole, the reason why this is so important, is kind of our gateway to be able to calculate other unknown things in a given problem. So let's look at an example of how we actually go about this conversion. So let's say our problem is how many molecules of water are in 1.25 moles? Well, I know that 1 mole is going to be 6.02 times 10 to the 23rd. So if I have 1.25 moles of something, well, all I need to do is really just multiply by Avogadro's number. So 1.25 times 6.02, I'm not prepared, I need my calculator. I would get an answer of 7.525 times 10 to the 23rd molecules. So this is kind of how I would go about this conversion. If I were rounding to significant figures, my answer would be 7.53 times 10 to the 23rd molecules. Now, one of the most important parts here in terms of setting this up, or at least the way to think about it, is focus on the units. We are going to take something that we know, which is this. This is what we call an equivalency. And we are going to set it up as a fraction. Because 1 mole is equal to 6.02 times 10 to the 23rd. So this fraction essentially represents the number 1. Because it's the same thing divided by the exact same thing. They mean the same thing. And so this is how we are able to do this conversion. Now, when I set up my equivalency, one of the biggest things I'm looking for is how do I set it up so that my units cancel out. That is going to be one of the biggest hints and that I can give you, and one of the things that I'm going to be referencing a lot when we do these in class is focus on your units, get your units to cancel out. And more often than not, you're going to have the problem set up correctly. Now, one of the things that we can do here is this is how we get from atoms, molecules, particles to a mole. And if I were you, I would go ahead and write this on your mole map, just to serve, again, as a visual reference of this is what we use in order to convert from particles to moles and vice versa. So let's look at another problem here. So here we have 2.8 times 10 to the 22nd molecules. So we want to convert that into moles. So the first thing we do is take what we're given, which would be 2.8 times 10 to the 22nd. Oops, I can't spell molecules. Draw my X, draw my line, and then I would use my equivalency to convert between molecules and a mole. And my equivalency, again, is 1 mole is equal to 6.02 times 10 to the 23rd molecules. So if I look at my units, if my unit here is molecules, that's what's going to tell me what goes on bottom. So my molecules would go on bottom, which is 6.02 times 10 to the 23rd, and 1 mole would then go on top. Now, when you do these calculations, and I would encourage you to take out whatever calculator you're going to be using and actually do this on your calculator. Because this is typically a calculation that you're not used to doing. And when you're putting this in, one of my biggest hints is put this number in parentheses when you do the calculation. Because the answer that you should get on your calculator is 0.047. I'm rounding for significant digits. If you didn't get that, then you entered it into your calculator incorrectly, and I would try it again, starting with putting my Avogadro's number in parentheses. Now we can also convert between grams and moles, and this is where we use the molar mass. The molar mass becomes my equivalency. So let's look at this problem. How many grams are in 1.25 moles of water? So step number 1 is I write down what I'm given, which is 1.25 moles. I draw my X, and then I draw my line. And then what I need next is my molar mass of water. Well, my molar mass of water is H2O. If we go through the calculation relatively quickly, I have the mass of water from the periodic table is 1.01, and I have 2 of them, so I'm multiplying by 2. Oxygen is 16. I multiply by 1. I get a molar mass of 18.02 grams per mole. So this is my equivalency. This is how many grams are in 1 mole of water. So I look at my unit, which is a mole. So 1 mole would go down here on the bottom, and my 18.02 grams would go on top. As a result, my moles would cancel, and I would get an answer of 22.5 grams. So it's basically the same principles in terms of setup as these 2 problems, but I'm using a different equivalency. In the one previous, I'm using Avogadro's number. Here, I'm using the molar mass. But I still am setting it up the exact same way. I write down what I start with. I place my units so that they cancel out. And then I just do the math. I just multiply straight across. So here you can see we have an additional thing that you would write onto your mole map on the back of your pink sheet. So you should have 2. So here we're looking at 1 mole is equal to the molar mass. So again, I would write that down just to give yourself another visual guide as to what do we use to do these conversions. So why don't you go ahead and pause the video and do this one on your own. Okay, so let's see what you came up with. So walking through this again, I start with what I'm given, which is 25.5 grams. I draw my X, I draw my line. As I look at my unit, I know that grams has to go on bottom so that it cancels, which means my 1 mole will go on top. So, how many grams? This is what the molar mass is. So the molar mass of sodium chloride, which is NaCl, is 58.44 grams. So then that's what goes down here, grams per mole. So then my grams cancel. So in doing my math, I would do 25.5 times 1 divided by 58.44, and I would get an answer of 0.4 436 moles. Okay. Now let's try a different sort of problem. So here we're going to start with molecules and we're going to go all the way to grams. This one is a little bit different because we're going around. So we're actually going to start here, go to moles, and then once we're in moles, we're going to go to the mass. So we're going to just combine these equivalencies into one problem, but our process is still exactly the same. So what do I do first? I write down what I'm given. So it's 2.75 times 10 to the 24th, and this is molecules. I draw my X, I draw my line. I look at my unit of molecules. So that's what's going to go down below. Moles is going to go on top. How many molecules? Well, it's 6.02 times 10 to the 23rd. Now, you can just do this right now and just do 2.75 times 10 to the 24th divided by 6.02 times 10 to the 23rd. You can do that now and then do the next calculation, or you can continue on. So I would look at my units. I have, well, let's just go ahead and cancel molecules. I can cancel out my moles, and my molar mass would go on top. Well, the molar mass of strontium chloride, I got to calculate that real quick. Comes out to 158.52. You might come up with something a little bit different. I'm just using the periodic table in the room that's on the wall. The one that you might have might round a little bit differently, the masses, but it should be close enough to that. So then to do this, I would just multiply straight across, so 2.75 times 10 to the 24th times 1 times 158.52, and then I would divide in parentheses 6.02 times 10 to the 23rd, and I would get an answer of 724 grams. If you want to do this piece by piece, meaning do this first calculation, hit the equal sign, and then do this calculation, and then do the equal sign, you can do that. Excuse me, you'll end up with the exact same answer. So this is kind of how we would use the mole map. You can go back and look at this problem of how we used this to help us go back and forth between molecules and moles, and then we use the molar mass to get us to go back to moles and grams. And that is mole conversions.